Mac OS X and iOS forensics related to FSEvents. Really awesome artifact that every Apple examiner should be looking at. If you're not, you need to start doing it. So a bit about me, I work with GC Partners. I'm digital forensics expert, part-time researcher, absolutely love research, part-time programmer. So importance, once again. Okay, so we're gonna discuss all of this in great detail later, but it records historical file system activity over time. Currently, once again, not being utilized as much as what it should be. Contains user and operating system activity, including creations and deletions, renames, permission changes, and so on. You can identify the names of files that have been deleted within FSEvent logs. And I've identified what has changed for those files of interest that you might want to be looking for. So our agenda, we're going to cover an introduction, high-level overview of FSEvents. We're going to look at parsing FSEvents, interesting artifacts, and of course the caveats that you should be aware of for these artifacts. So FSEvents, or file system events, are changes to objects on a file system that has been a volume that's been mounted within a Mac OS. So if you're familiar with Windows and the NTFS file system, then you may also be familiar with the USN journal, which also contains historical changes of file system objects over time. So these are generated by the Apple OS FSEvents API. It was introduced in 10.5, and up to 10.6, it only included changes to directories. So that's important to know if you're working with an older OS and you're looking at your parsed FSEvents or what have you, and you're seeing that it only contains directories. That's why. 10.7, they introduced file events, which is great because now we can see changes to files on the file system. So these are stored in gzip logs, and a single log can span multiple days, and the entire contents of the FSEvent directory can span days to months. These are found in iOS devices, OS X devices, and external devices that are plugged into a Mac. So let's look at the location of FSEvent logs. Within OS X, these are located within the system partition, the root directory of it, in /.fsevents_d. The location within iOS, there are multiple that have been observed, is the data partition in private /vars/.fsevents_d, and that contains user-related data or user-related activity. For system-related activity, you'll find it in the root./.fsevents_d, and in the developer patch, which in my testing I've seen to contain developer patch-related activity, was located in the developer patch folder under /.fsevents_d. Now, looking at the image to the right, this is the FSEvents_d directory in an OS X system. This is not normally accessible by a user and requires elevated privileges to access it. So you can't see it even by default, noting the dot at the beginning, which means it's a hidden directory. So it takes elevated privileges and knowledge to be able to access this directory. The name of each file within that directory is represented in hexadecimal format and represents, once converted to decimal, the last event ID within that file plus 1. So let's look at the life cycle of an FSEvent record. This will help in understanding exactly what's going on behind the scenes from a high-level perspective, of course. So FSEvents initially are stored in memory. When an object receives a change, the FSEvents API checks to see if it was already given an ID within memory based off of its relative full path. If it has, if it has not, it will assign the next available event ID and add it to memory. If it has been already assigned an event ID, it will coalesce the changes that were made to a record or a full path into one event, so you won't get multiple events for one file. You'll get a single one, all coalesced as one record. and stored in memory, keep it stored in memory. And many changes will occur. You know, many other files will get changed, and when the memory buffer is full or a volume is unmounted, this will get flushed to disk as a gzip archive file within that .FSEvents D directory. So next, let's look at decoding events. So if we unzip that archive file or uncompress it, there can be contain multiple pages within the FSEvent record, and the magic header for that is 1 SLD. Each log, when parsed, can contain up to 5,000 events. I have not seen an instance where there was more than 5,000 events within an uncompressed gzip file that was parsed related to FSEvents. And this is also important to note, is that when the events are stored in memory, they're stored alphabetically. So when you parse an FSEvent log, you can also expect that they're going to be stored, or they're going to be parsed alphabetically. So you would have to know to sort appropriately to get the best chronological order for those events. So each record consists of 3 components. The full path, which is the relative full path to the file system object being changed. The event ID, which is, according to Apple, is monotonically increasing. So it bears no reference to a time base. Apparently it's not time-based. And lastly is the record flags. So the record flags include the kind of object that's getting the change and so for instance, file folder, and the type of change that's happening to that file, or the reason flags. So here we can look at the different kinds of flags we can see. So for the type flags, it can be a file or folder, hard link, or a symbolic link. And the reason flags, or what happened to that item, is created, removed, modified, renamed, permission change, inode metadata, finder information, mount, unmount, last hard link removed, end of transaction, and document revisions. So this is the hexadecimal format of an uncompressed log file. For my presentations, I like to have hex. That's what I do all day long, is look at hex. So it has to be here. Sorry for those of you who don't like it. So let's take a look at the magic header. That's our 1 SLD that indicates it's the start of a page within that uncompressed FSEvent log. The total header length is 12 bytes long. And after the header, we'll have the start of our first full path. And in this example, this was taken from a thumb drive that was plugged in, and this is activity that I had generated myself, so that's a file that I created there. And we're not going to discuss the flags, decoding the flags in full detail here, but you can reference my documentation on my blog, which is NicoleIbrahim.com, if you want to look at more of that. So just going back to the full path, it is terminated by a null 00. And then next is what you see as the event record ID. Following the event record ID is the flags. And that basically continues on until you hit the next magic header of 1 SLD. So let's look at parsing events. There are a few tools that I'm aware of that currently parse offline, on-disk FSEvents. One of them is Blacklight. It's a closed source and paid software. It does a great job at parsing FSEvents. And you can read their their help manual to determine exactly how to do that, but it's through the advanced options when you're parsing. And I believe it's system log that you have to select to parse FSEvents. And you can download it at their website. There's also an open source and free tool called FSEvent Parser, which is a Python-based script, and it's command line, and it also does the same thing. So let's jump on to interesting artifacts now that we've covered all the boring stuff. So everything that's been parsed here was used using the FSEvent parser Python-based script. And anything that I'm talking about here, this barely scratches the surface of what you can expect to see within FSEvents. I could spend all week long talking about what I have found within FSEvents. So let's start with trash activity. So within FSEvents, the Python-based tool will output the data to an SQLite database. So you can run queries. So to the right, I have a basic query of how to look for items related to the trash. So what you can see is, you can see files that were sent to the trash and emptying of the trash. So in my example below, these were items that were previously on my desktop. I had exported. You might notice that it says .fseventsd. That's because I was doing testing. So I extracted those out from my FSEventsd directory, put them on my desktop, and then later I removed them, which is if you look to the right of the screenshot, it says removed. So I emptied my trash. Next, let's look at the user profile directory or the user folders activity. We can look at activity within the user's documents folder, downloads folder, desktop, pictures, whatever is under the user profile directory. And I have a basic SQL script there. So within the example below, I had downloaded in Microsoft Office 2016, I believe I can't see it right now, but PKG. So I installed Microsoft Office, I downloaded it. Well, this indicates that I downloaded it. I did download it, it's right there. It's in the downloads directory also. And then I downloaded a Navicat DMG because I want to be able to query my databases. And within a desktop, you can see that there are creations there for the .fseventsd folders that I was telling you about that I had copied to my desktop, getting the created flag for my testing. So let's look at website activity or internet activity that you can find within FSEvents. So you visiting a URL within Chrome and Safari, I haven't tested Firefox, will produce internet-related files that contain URLs related to your internet activity. So in this example, we can go with the bottom example. I believe it was in Safari. I was visiting WFAA.com. I live in Texas. I need to know if I'm going to get hail. I want to keep my car protected. So you can see the specific URLs that I was visiting on WFAA.com. So mount activity. You double-click a DMG, the OS is going to try to mount it. You plug in an external device, the OS is going to try to mount it. Shared network drives, try to mount it. Mount activity is also recorded within FSEvents. So you can see when drives were plugged in, when DMGs were mounted, and it'll get the mount flag. And when it's unmounted, it'll get the unmount flag. And something that's also interesting that I noticed is that the /net and /home folders will get mounted when the system starts up. So you can filter those folders out and get approximate dates for when the system was booted. So next, let's look at iOS. And iOS is pretty interesting. And I want to do a lot more testing on it, and from what I've seen with what I have, you can get a lot of information also, and probably even relate that back to some of what Sarah and Heather was talking about with continuity. So let's look at iCloud synced files from other devices. So in this example here, I have created an SQL query that filters for Apple Cloud Docs. What you can see here is a reference to trashes, .trashes. I don't know of any reference to trashes on an iOS device. So these FSEvents, just to make it clear, were from an iOS device, an iPhone. So there's references to Cloud Docs for the .trashes directory. So what happened here was another device, a desktop computer, had sent these files to the trash, and then the iCloud syncs these metadata files, you can see with the .cloud extension, to the phone. So we can see activity that was occurring on the desktop computer, even though these files are coming from the phone. So next, let's look at internet activity. Very similar to OS X. You can see, internet activity related to URLs that were visited and what was created for, the browser that was generated with. So there was Red Snow visited, which is a jailbreaking website, which is the very first entry. And I should note that To access FSEvents on an iOS device, it has to be jailbroken, so it's not easily accessible. So email activity, you can also see this on OS X too. So we're still in we're in iOS right now. These are all FSEvents from iOS. You can see the attachment names of attachments that were downloaded. And you can also see activity related to sent items in the inbox, and so on. So next let's look at the caveats related to FSEvents. We're going to talk about lost FSEvents, lack of timestamps, which is a pretty big one for a lot of people, external devices, anti-forensics, and coalescing of multiple changes. Okay, so the problem here is we have lost FSEvents. You get a system, and there's no FSEvents in the directory. There's just a single file called a UUID file. So what happened here? Okay, that could be the result of a hard reset of a system crash, or not properly mounting a volume. That's a big deal. FSEvents are stored in memory. So what happens if FSEvents you have an external device plugged in and you pull it out? It's gone. You can't write it to the external device if it's not there, if it's not properly mounted. And system upgrades. For some reason, I'm not sure why, but system upgrades apparently appear to cause FSEvents being removed from the directory. Could be, once again, not properly booting during the process, who knows. You can carve for gzip files if you want a remedy for this problem. You might not always get it back, but I have seen a large number of FSEvents being carved from unallocated space. Lack of timestamps. As previously mentioned, there's only 3 components of an FSEvent record within that log. It's the event ID, the full path, and the flags. There's no timestamp there. So how are we going to know when something changed? How are we going to know when something happened? So we can use temporal data right now to pull from the name of Apple's system logs. So ASL likes to name their system logs based off of the date that it's going to track. So we can take that name, and then the FSEvent parser script puts it into a separate column called other dates. So you can get an approximate time frame of when something happened. External devices. So unsafe removal. You've seen it when you have a drive plugged into a Mac, you unplug it, you didn't use unsafe removal, and it starts screaming at you. Ah, unsafe, no, don't do it. So when you do that, your FSEvents are lost. Because once again, they're stored in memory. It wasn't properly mounted, or it wasn't properly mounted for that matter. Okay, so you did a safe removal then, but it didn't finish writing to disk. Once again, they're lost. You can see this by looking at the write light on some external devices. If it's still flashing, it's still writing to disk. If you pull it out before that's finished, they're gone. File system compatibility issues. I've also seen on non-HFS plus formatted external devices that it doesn't always write FSEvents to the drives. So remedies, you better hope that that person properly mounted that drive. Otherwise, you're not going to see them there. You may also try carving, though, the external device. If you do see that on an external, say a FAT32, there's an FSEvents D directory. You can try carving for FSEvents to see what you get. So coalescing of multiple changes. The Events API coalesces multiple changes into one event. So there's a huge problem with this. Unlike the USN journal, it'll put each line for each change that happened to that file, which is beautiful. We know exactly in what order everything happened. Here we don't. We don't have the order that something happened. I can create a file on my desktop, then remove it, and modify it, and then recreate it again, but it has completely different contents. You'll only see that as one entry. That was 2 separate files. So that's a huge deal. You have to be aware of that. So anti-forensics. I haven't seen this in the wild, but apparently you can place a no-log file in the FSEvents D directory, and it will not monitor FSEvents. So if you don't want anybody parsing your FSEvents, you want to put that file there. So yeah, FSEvents won't be recorded for that volume. So there's no remedies. However, if you get an image of a system or you image a system and that no log was there, you're not going to get FSEvents. But however, the privileges and permissions that and the advanced knowledge that you would need or a user would need to do that is, may not be likely. However, before we do questions, I do want to say that there are amazing artifacts within FSEvents. And as you saw, I mean, internet activity, mounts and on mounts, anything I do on my desktop, downloads directory, email, and syncing from cloud, I can see activity on one device, on my phone that had the iCloud syncing. So there's a lot of good information there. You just have to understand the caveats involved with it.